Welcome you all. I am Karthik Gupta. Today we are going to discuss the topic called problems on trains. Okay, so problems on trains, time and distance, actually speaking, both are same. But the syllabus is very huge. Because of that reason, we have bifurcated time and distance as a separate part and problems on trains as a separate part. But the concepts what we are going to use in both the modules are same and similar. Okay, so now problems on trains. See here, whichever the exam you may take, whether it may be clerical, PO or SO, one problem or two problems you can expect from this module, and the problems will be very simple compared to your time and distance. But only the thing is, you have to analyze how to take the distance or how to consider the distance in this module. Okay, so now problems on trains, very simple. See here, whatever the concepts we have discussed in time and distance, the same concepts are applied here also. The speed is inversely proportional to time and speed is directly proportional to distance. So the formula what we use here is speed is equal to distance by time. Speed is equal to distance by time. So this is the formula what we are going to use here also. But one thing you have to analyze, see here, what is the distance traveled by a train if the length of the train is 100 meters which crosses the pole in 10 seconds. Okay, they are going to ask you the question like this. The length of the train is 100 meters. The length of the train is 100 meters which crosses a pole in 10 seconds. So what is the length of the train? So consider there is a pole. In front of that pole, a train is going to pass. See here, a train is going to pass in front of the pole. So the pole is standing and the train is moving. If you consider that the train is not moving and the pole is moving, then the entire pole or the pole has to travel the entire length of the train. See here, let me tell you again, a pole is there. Okay, in front of that pole, a train is moving. Now, pole is a standing object which is not having any movement. But train is a object which is having a movement. So train is passing in front of the pole. If you consider that the train has stopped, train is having no movement, and the pole is having the movement, then the pole is going to move or the pole is going to travel entire the length of the train, or it is going to travel the length of the train. Therefore, here the distance will be length of the train. In your exam, they may ask you the question like this. A train is passing in front of the pole, the train is passing in front of the man, the train is passing in front of the electric pole. Okay, so these type of questions they are going to ask, where the distance is nothing but the length of the train. Why? Already I have explained. Here pole, in front of that pole, the train is going to pass. If you consider the train is not passing or the train is not moving, if the pole is moving, then the pole is going to move the entire distance, that is the length of the train. Okay, so therefore the distance traveled is nothing but the length of the train. Okay, so distance is equal to length of the train when it is going to passes an electric pole or a standing man. Okay, now we are going to get one more condition. The condition is like this. And train is going to pass as a platform. See here, there is a platform which is not having any movement. So in front of that platform, the train is going to enter. So now, what is the total distance traveled by time? See here, the train, the first bogie of the train is going to enter, the next, the second bogie, the third bogie, fourth bogie. Like that, when the first bogie has entered the platform, the last bogie has not entered the platform. When the first bogie is going to leave the platform, the last bogie is not going to leave the platform. Means what? Even though the bogies are passing the platform, but the entire train is not passing the platform. entire train is not passing the platform. See here, in front of the pole, the entire train is going to pass, means the pole is going to pass the entire train, that will be the total distance. But here, the entire platform, for example, 150 meters is the length of the platform. Let us take 150 meters is the length of the platform. The entire platform has to cross the entire train, or the entire train has to cross the entire platform. So here we are going to take the distance as, length of the train plus length of the platform. Okay, so the entire train has to pass the entire platform, therefore we are going to consider it as distance is equal to length of the train and length of the platform. If they are going to ask you the bridge, then distance will be length of the train plus length of the bridge. If they are going to tell you both the trains are moving, then total distance is equal to length of the train first plus length of the train second. Okay, so when you are going to get a negligible distance like pole or electric pole or a man, then we can neglect that distance and we are going to take only the length of the train. But when we get a considerable distance like the length of the platform, the length of the bridge, the length of the train, the length of the tunnel, then we are going to add the length of the train or the length of the tunnel, okay, the length of the bridge and length of the platform to the train. Okay, so the total distance will be length of the train and length of the platform, or length of the train plus length of the bridge, length of the train 1 or length of the train 2. So this is the different concept in trains when compared to time and distance. In time and distance, directly we are going to take the distance, but here we are going to consider the length of the two trains as the total distance. Other things are all same. The relative speed, the speed conversion, the time conversion, speed is equal to distance by time, the relationship between speed and time, each and everything is same, okay, except the distance. Here we are going to consider the distance in this manner. Okay, let us solve the problems.